bit of a novelty doing a in-person talk.
Yes.
Quite nice. Sorry, security there. Right. Are we recording? Shall I start?
Yeah.
Yeah. Okay, perfect. So thanks very much for having me. I suppose just to very briefly introduce myself. So I've been with Network Rail for more than 20 years now. Said a bit quietly. But in this role just since January. So this role came.
Turn off aeroplane mode.
This role came about to basically respond to weather-related incidents on behalf of the region. So there's equivalent role in each region with a weather risk task force. Although on Wales and Western we're called the Climate Change Task Force, and we respond to things like Carmont, there's the adhesion event at Salisbury and other such weather-related impacts. I trained as a meteorologist and worked for the Met Office for 6 years as a climate scientist, and then I've been at Network Rail ever since. So that was just a brief introduction. Right, yeah, that works. So, and what I'm going to talk to you about, I've just put into 4 hopefully logical sections. So we'll start off looking at the impacts of weather on the railway, and then go on to think about the question of resilience. So what does that actually mean when we talk about resilience of the rail network, resilience to weather? Then we'll look at some climate change impacts. What impact might they have on the railway? And then finally, the big question, how can we adapt to climate change? So on to the first one. So I'm going to talk about 3 main elements, meteorological elements: temperature, rainfall, and impacts from the coast, sea. Obviously, there are a whole plethora of weather parameters, and you can just look out the window today to be hit in the face by some of them. But yeah, these are kind of the main ones that we're going to see a big change in over the coming decades, and also they're responsible for many of our most severe impacts. So looking at heat to begin with, July 2022 saw record-breaking temperatures across the UK. We actually had 46 weather stations which had their previous records broken, and 7 of them went over 40 degrees C, which was the first time that had ever happened in the UK since observations began. The peak was 40.3 degrees in Lincolnshire, and using statistical analysis, it was roughly about a 1 in 100-year event if the climate was steady state. However, we know that the climate is not steady state, and so those sorts of events could actually happen 2 or 3 times a decade by the end of this century. So what impacts does heat have? As P-way engineers, I'm sure there's some in the room, you know, I'm sure you know the impact on the rails, can lead to buckles. We also could have line-side fires. But actually last July, our infrastructure was pretty resilient on Wales and Western region, but we did still cause a huge amount of disruption to passengers. And that in itself can create risks when you've got a lot of people stranded in very, very uncomfortable temperatures. OLE can obviously also be impacted, although Series 1 that we have for most of Western is more resilient than most. And then we also need to think about the other extreme, low temperatures. So we can have ice in tunnels, points failures, and broken rails as a result of cold, extremely cold temperatures. So now I'm going to talk about rainfall. And the next slide shows some different impacts we have on the railway. So this one is flooding at Flaxbourton, south of Bristol. We've got another one here that is on the Somerset levels, that's Fordgate, near Taunton, near Bridgewater. Is this Brunel's legacy? I mean, he built this amazing Great Western Main Line on low-lying areas, as many railways are, flatter areas. And then we've got the stunning section along the coast in Devon, which again is now quite vulnerable to weather. So potentially the railway is going to be vulnerable for that reason. This is Chipping Sodbury tunnel and cutting, where this was many years after Brunel's death, but again, the railway was built through an aquifer because the very wealthy owners of Badminton House nearby didn't want to be able to see the railway. We can certainly reap the rewards of that these days. So yeah, it causes a lot of problems now. Electrical equipment does not mix well with water, and we have failures due to that. And then the other major impact of rainfall is on earthwork stability. So landslips, such as what happened at Carmont in 2020, and then we had our very own example near Teignmouth in 2014, where we had 20,000 tonnes of dislodged material that had to be removed before we could open the line and run trains again. And then finally, I'm going to talk about coastal impacts. So we have got a lot of coastal railway on this region. And obviously I'm going to talk about Dawlish, very, very famous weather event in 2014. So these are some of the waves that were seen in 2014. That's at Dawlish Station. I'm sure many of you have seen these pictures before. And those sorts of conditions left us with a major structural failure there of the seawall. Common theme here, the wall was lower at that point because some wealthy people in the houses adjacent to the railway didn't want people looking in their living rooms. So yeah, we've made a rod for our own backs, or the people that built the railway have. And then this is, I didn't want it all to be about Dawlish, so this is Penzance. Pictures there courtesy of Roger Winnan. And Penzance, again, subject of flooding, track flooding, overtopping. And we can have other impacts as well as structural and flooding impacts from the sea. We can have stranded trains, which is something that we've seen every so often on the Dawlish kind of area. Track circuit failures, if we still have track circuit failures near the sea, and more electrical equipment impacts as well. So what does all that add up to? What does that mean for the train service? So it costs us hundreds of millions every year nationally in Schedule 8 payments in the industry. So delays, read that as a proxy for delays to customers. This is showing the last 15 years, and you can see that the main impacts have been wind, flooding, with other impacts perhaps less so. But the other thing to note is it's hugely variable year to year. So it actually makes it very, very difficult to predict what our performance will be in any particular year, which is something we do every year. We say, right, how many minutes delay are we going to budget for in the next year? And we have it period by period through the year. But then the weather happens. It's not the same year on year, very, very variable. So invariably we miss our targets, or we have something quite different to deal with than what we maybe were expecting. And this excludes the costs of repairing, renewing, kind of basically putting the railway back together after it's failed. It excludes Schedule 4 costs where we have a more extended weather-related failure, and it excludes the kind of wider weather-related impacts. So there's a massive impact of weather on the railway today. Okay, so what does resilience mean? I think this is a really interesting question, and one that we need to think about before we go on to then look at what we're going to be trying to be resilient to in the future. So this graph shows a kind of measure of performance, and there are 3 lines on there. So the green one is normal weather days, the yellow one is adverse weather days, and the red one is extreme weather days. So you may know that we get weather forecasts every day into our control rooms, and most of those weather forecasts, the majority of days will have benign normal weather. On days where we're expecting something a bit outside of that, we might have an adverse alert, we might have an extreme alert. So just to give you an example, for wind, adverse is gusts between 50 and 59 miles an hour, and extreme would be 60 miles an hour or more. For hot temperatures, adverse is more than 25 degrees C, up to 29, and then extreme is more than 29. And similarly for all weather parameters. So what can we see from that? Well, obviously performance is better when the weather is more benign. That's probably, you could have told me that. When the weather is adverse, those are the kind of days when the general public wouldn't necessarily think, oh, this is really extreme weather. Most other infrastructures out there would be running, roads would be open. And so it's really not great for the railway to suffer on those particular days, because most people would not perceive them to be a problem. So, but we do get a dip in performance, which you can see between the green and the yellow line. On the extreme days, those are the days where there will be other types of infrastructure impacted, and many people might stay at home. There'll be, it might be in the news instead of just at the end of the news. So it's kind of, there's more understanding, I suppose, in those days when we get disruption. So what is resilience? So just to define the term, I mean, this is the general term resilience, and I think it applies equally to if we're talking about, say, our own mental health, or if we're talking about how robust the railway is. It's a good general definition: the ability to bounce back quickly from negative impacts. So I think we should be looking to close the gap between the green and the yellow lines and become more agnostic to those adverse weather days. We should be looking at designing and building our infrastructure to withstand what we would expect to get on an adverse weather day. And on the extreme days, what we want to avoid is those really big dips in performance. So we want to be more resilient, which doesn't mean we don't feel any impact from them, because of course that would be pretty much unfundable to build a railway that could withstand all extreme weather. But what it means is that we can bounce back from those events more quickly, get trains running more quickly, and that's what resilience really means, I think. So some examples of resilience. I'm going to start off with, this is off patch, I'm afraid. I wasn't sure if everything had to be on Western Region. So this is Conwy Valley, so in North Wales. And this suffered a lot of flooding. It's severely affected by flooding in 2015, 2019 and 2020, with prolonged line closures, as you can see from the first picture. The second picture shows a common situation that we actually have over a number of different sites. So you have a river flowing, you see on the left-hand side, flowing under the railway. And that's the kind of the direction of flow is from the south to the north and east in that picture. And then when that river gets very high, bursts its banks, and that flow then is looking for an alternative way to cross the railway, and get to the lower other side, washes out the railway, washes out the formation, and that's where we suffer as a result and end up with something like the picture on the left. So this was then repaired and renewed with new rock armour, shown in that picture on the right. So the cost of the kind of accumulated flooding impacts on this line, even though North Wales line is hardly kind of, the throat of Paddington, it was still around about £6 million, and an estimated £8 million was saved in the first 2 years. So flooding did occur, but the railway was able to be reopened really quickly. And passengers are coming back as well, because they now trust the railway not to be washed away. So that's a really good news story. This is even more rough patch. This is Carlisle. So this shows the flooding in Carlisle. So it first happened in 2015. Well, Carlisle's flooded many more times than that, but in 2015, and the railway was closed for 2 weeks because of the amount of damage that happened to signalling location cases and other equipment. So they were then raised onto platforms like this. You can see them in the picture on the left as well. When it flooded again in February 2020, the railway was then able to be reopened in just 24 hours. And this is an example back on Western Region. This is Hinksey, where we did the same thing in a flood alleviation scheme in 2016-17 sort of time, I think it was. We raised our location cabinets up onto platforms. So another example, going back to Dawlish. Let my slides catch up. So this is the first phase of the South West Rail Resilience Programme along the coast near Dawlish and Devon. So 350-metre long new seawall was installed. Foundations went down to the bedrock. The wave return that you can see on top of the seawall there deflects wave energy out to sea, and that was about 1.5 metres higher than the old seawall. Just looking at Emma for confirmation there. We have another expert in the room here. So this was designed to prevent a structural failure like that happened in 2014, a kind of undermining and washout. It also reduces overtopping by 90% compared to kind of current levels in the current climate, and so therefore reduces track flooding, impacts on train service, and so on. On the right-hand side, we've got a picture of some modelling that happened in HR Wallingford in Oxfordshire. And this is actually for the second phase of the seawall. So a scale model showing how much overtopping different shaped walls and heights actually, what it does is it captures the overtopping in this kind of swimming pool sized tank, and so that helped feed into the design. And then this picture was taken in 2020, partway through the building of the phase 1 seawall. Now the wave return profiles here were put on partially, so you've actually got a wave here hitting the seawall without the wave return, and you can see the volume of water that gets over onto the promenades and the railway, and then where the wave return profile is in place, you can see that much more of that wave is deflected out to sea. Still some spray getting over there, wind blown spray, but the volume of water is being deflected. And then a final one, this is Black Bridge in near Machynlleth. So the River Dewlas floodplain, and this has been lifted by a metre after numerous closures where high river levels damaged the bridge, and multiple closures of the Cambrian line. So now that the bridge has been raised by a metre, and that will buy us some resilience, certainly for some years to come. So let's talk about climate change impacts. So I think probably everybody knows the headlines of warmer, wetter winters, hotter, drier summers. But actually what we want to know as railway engineers is, what are the extremes going to do? Because that's really where we get most of the impact. So at the moment, you can see on these diagrams, so the one on the left shows the kind of baseline climate, 1981 to 2000, and then different emission scenarios or different kind of levels of warming that might be experienced. And it shows the number of summer days. So that's defined as a day with a temperature exceeding 25 degrees. So 15 to 20 days at present on latter half of the 20th century climate were hitting that kind of summer definition. That could treble in some areas on the western, even under the lower emission scenarios. So I think what we are going to be seeing is more kind of periods of extreme heat and more heat waves in the summer. Similarly, frost days, as you'd expect, will reduce, but that doesn't mean we won't get them. So in terms of the kind of the problem about where do you have your stress-free temperature of rail, and do you move it up or down, you know, we are still going to be expecting a large temperature range that goes below zero. So I think it's quite a thorny problem. And then just to bring this right up to date, I've got just a little bit of climate information from this September. So September 2023 was the hottest on record globally. This is global average by really quite some margin. So you can see that's absolutely smashed previous years. So I just wanted to throw that in there. Sorry. So now let's look at rainfall. So again, I'm going to look at those three parameters, which is rainfall, temperature, rainfall, and coastal impacts. So in terms of rainfall, again, it's the extremes we really want to know about. So looking at rain days, what does the intensity look like? What does the change in intensity look like? So the top is the summer, the bottom is the winter, and the changes in percent of the amount of rain on those rain days compared to the baseline 1981 to 2000 climate. So you can actually see that in the median and the upper estimate, there's some quite significant increases in the intensity. In the summer, it's drier overall. So what we're seeing is those isolated thunderstorms are going to be more intense. In the winter, we've got wetter winters, but we're still expecting more intense rainfall. So the warmer climate, more moisture in the atmosphere, greater rainfall volumes. Right, I'm now going to talk about sea level rise as the third area. So that shows the global picture for sea level rise. And sea level rise is a really tricky one in terms of in the kind of world of climate prediction, because there's lots of thorny feedback loops that could or may or may not happen relating to the ice caps, for example, on ice sheets. So, but you can see that sort of roughly 0.5 to 1 meter is expected as a global average. And then that dotted line shows a kind of very low likelihood, high impact scenario where we have got an ice sheet instability feedback coming in. And in terms of kind of the really long term, we could see up to 15 meters by 2300, because there's a kind of lag in the ocean, and that those deep ocean levels take a long time to warm up, but when they do, they're going to have a big impact on sea level. So what about the UK? That's what we really want to know in this room. So these show a kind of a low and a medium scenario, sorry, medium and a high emission scenario for the UK. And you can see that the sea level rise is greater on the south coast than it is on the north. And that's might be surprising, but that's actually because there's an offsetting impact of the land masses moving and tilting. So again, so we've got up to 0.7 meters in the south there. The Dawlish project used a value of 1 meter, so we should be all right. Tonight will be a good test. So now let's get on to how we might adapt. So going back to this picture, we talked about resilience earlier and what it really means, and about closing the gap between these lines. So in the context of adaptation, what does it mean? When I say adaptation, I mean adaptation to our changing climate. So adaptation, defined by the World Economic Forum as adjusting behaviour and building improved infrastructure to better cope with changing weather patterns. So does being kind of adapted to the climate, does that mean that we're going to be maintaining a steady state? In this picture here, I mean, I would argue that we probably need to increase our weather resilience out there today. So we've got a potentially bigger task ahead of us to get to the point where we can say that we're adapted to the climate. There's another picture to help us think about resilience here. So it's a general diagram. It says increased storm intensity and frequency on the bottom right there, but actually this could be any weather variable. So it could be your maximum temperatures or your rainfall intensity. But wherever we've got an increasing trend, like we have in those two parameters, natural variability is superimposed on everything, and that is huge. So natural variability, we're always going to have these really big interannual variations. So you might have a critical threshold. It might be a drainage threshold, or it might be a track temperature threshold. If you think of having a critical threshold, sometimes it gets exceeded, but it's quite rare in today's climate. So sometimes it causes you a big headache, but most of the time it's okay. As climate's changing, then we're going to start seeing that threshold, that critical threshold, being exceeded more frequently. And it will start to become business as usual to get those sorts of temperatures. So we need to make a step change in that critical threshold to adapt to climate change. You can see that the kind of orange block here represents raising of that critical threshold. And it might be that you already have some resilience within that threshold. So there might be some inherent resilience that you already have. So you could actually stand to go a bit beyond the threshold as it is now. So that's kind of your kind of inbuilt resilience. And then you're going to have the need to adapt as well beyond that. So coping range plus some adaptation to raise that threshold, and then get to the point where again you have a largely resilient asset. So that one's actually getting back to the steady state where you're only having the extremes impacting you on rare occasions. So now let's talk about adaptation pathways. So they're broadly understood to be a kind of a sequence of actions that you kind of map out in time, and they can be implemented progressively. So it doesn't all have to happen right tomorrow, depending on future climate and other variables. So let's take this example. So river and sort of fluvial flooding. If you have an existing system such as drainage, you could go on a couple of different paths. The top one shows kind of a structural intervention, kind of changing the infrastructure. So ensuring the drainage asset replacement. So whenever you're renewing it, you're enhancing the capacity. And then if that happens over a period of time, you might have dealt with a proportion of your assets, and then there might be some residual assets that you then need to go in and proactively upgrade. So as flooding severity and probability increases along the bottom axis, you then get to more and more extreme events. And so you might in the future then also have to consider something like raising the track or closing the track or rerouting the track. So those are different options depending again on your funding environment and what the appetite for having a certain level of railway performance is. And then the lower path is looking at kind of what we call non-structural changes, so more kind of management actions. So it might be that you have some temporary flood barriers that can be brought out when you have flooding or heavy rainfall in a particular area. You might decide to change your timetables to make them more robust. So even though you're running fewer trains, your passengers know what they're have more certainty around how they can get to their destination. And then finally, as things get worse, it might be that you have to accept a reduction in reliability. So that's adaptation pathways thinking, and this is kind of broadly thought of as the best practice, and it's what we need to do, and we will be doing in the next 5 years for all of Wales and Western. We'll be thinking about different sections of railway and then looking at what actions need to happen and when in order to get to an adapted position. So the output of that work will be a kind of a series of interventions that happens over the coming decades. So the best example, back to Dawlish again. Dawlish was a really excellent early example of looking at this type of thinking, basically. So the Exeter to Newton Abbot resilience studies done by CH2M in shortly after the 2014 event actually looked at the whole section of coast between Exeter and Newton Abbot and looked at all of the sites that were vulnerable and identified the kind of priority and roughly which decade or control period they would need to be basically made resilient in. So it was identified that there were some priority sites that needed urgent intervention, and that's what made the South West Rail Resilience Programme. And these 5 sites were taken forward. So we have the Dawlish seawalls, 2 phases, and then 3 different cliff sites. One thing that's absolutely key in all of this conversation is thinking in terms of line of route. We're only as strong as the weakest link. So if you deal with 4 of them and don't deal with the 5th, then your network to the southwest is still going to be closed, and you need to you're still going to be disrupting passengers. So how do we make the case for investment in this, what is effectively a climate resilience project? So the economic case for investment in a climate resilience scheme is actually pretty strong, because if you think about benefit to cost ratio, the costs is your capital cost up front of doing the intervention, but your benefits is basically avoided costs of, and then there's a kind of a triple impact. So you're avoiding the disruption, you're avoiding the impacts, the secondary disruption costs, so kind of wider economic costs of disruption to passengers, and you're avoiding repeated reinstatement costs. So if you can imagine a kind of landscape of climate into the future where these impacts are happening more and more frequently, it kind of accelerates. And so the costs, you know, if you look sort of 30 years ahead, you're suddenly getting huge amount of costs that you would be avoiding if you invest today. So that's how the business case worked for South West Rail Resilience. So just wanted to look at this one because it's particularly photogenic. So and I haven't talked about a cliff one. The third phase of the South West Rail Resilience Programme, looking at the threat from the cliff. So this is Parsons Tunnel North Portal, and here we've built, Emma and team have built a 109-metre long rockfall shelter, some nails and netting to the cliff, and as you can see, the rockfall shelter is coloured concrete, in keeping with the red cliffs, and it was built by this rather novel way with a gantry crane, which you can see in the picture on the right there. So that slid up and down on rails outside of the rockfall shelter to lift into place 185 precast sections. So it kind of removed the need to mobilise and demobilise a crane on every single shift. So saved a huge amount of time and money. So that's now complete, that project, as are the first two phases, the two sea walls, and the fourth phase, which is cliff resilience between Dawlish and Holcombe, is well underway as well. So the fifth phase is seeking funding for design in the next control period, and has a third of our high-risk sites for cliff stability on this whole coastal stretch. So see previous comments about only being as strong as our weakest link. We need to fund it. Or I should say the department need to fund it. Another picture there, just taken from a drone, showing project partway complete. And then the final example, this is one very much for the future, is Powderham Banks. So this is again down in Devon. So you can see on the map on the left, you've got the railway line following, that's the Exe estuary as it comes down, and then it comes to the open coast section and it will bend round and go past Dawlish. And there's a flood defence alongside, which is marked on the map, and that's maintained by the Environment Agency. It's a very old defence. I think they said it was built in the Napoleonic era, and the purpose of it at the time was to dry out some land for farming. But now it acts as the main flood defence for the mainline railway to most of Devon and all of Cornwall. So quite a critical asset. In March, it had a breach, which is marked on the map, and there's a kind of water made the most of some animal burrows that were there, and you can see the hole there on the map and how close it is to the railway. The Environment Agency spend about £100,000 a year on patching and repairing this. So the plan is that Network Rail will work with the Environment Agency on a feasibility study again in the next 5 years, and then we'll look at kind of what the adaptation strategy will be. There's another twist in the tail of this one, which is Dawlish Sand Spit. So this is again the railway running along the estuary, and then you've got this large sand spit out into the mouth of the estuary of the Exe estuary, which, as you can see, will provide quite a lot of protection to the estuary from the open sea in terms of storms and wave activity. Now, this is eroding. I don't even know how accurate this picture is because it's eroding at a rapid rate. The Environment Agency estimates it's about 10 to 15 years ahead of where they thought it would be, where it was expected to be. So this kind of exacerbates the whole need to deal with the Powderham Banks flood defence. So just finally then, what can you do? I think just try to think climate adaptation in all infrastructure decisions. If you can just try and sort of take cognizance of it, undertake a kind of a suitable and sufficient risk assessment when you're looking at projected weather conditions, and kind of the whole life of any assets, thinking about changes over the future. Embed those items in the requirements, and then just think what does resilience look like? You know, ask your clients how resilient does this need to be. If full future proofing is not possible or not affordable, then maybe thinking in that kind of adaptation pathway mode of thinking might be beneficial as well. Could it be modified at a later date to become resilient? This is a cabinet office idea, really, but I find this quite useful, and it's something that might help you, I guess, in terms of thinking of different levels of resilience. Okay, so from the kind of very reactive on the left to the kind of full, very proactive resilience on the right. So they've got all of these R's, 4 R's: resistance, being slightly resistant to the weather, but actually ultimately still having major issues with it. Reliability, actually, can we make things more reliable, like raising our load cases? Redundancy, so having diversionary routes, or having backup for different assets. And then finally, a kind of full proactive response and recovery. So we know what's going to happen, we know how it's going to impact us, and we're going to be very proactive in the way we manage it to minimise disruption. So I think, I mean, our kind of stated Network Rail's stated vision for managing climate is I have it written here, is for a railway that is increasingly resilient to the risks and impacts of both current and future climates, enabling passengers and freight to get to their destinations promptly, easily, and safely. So that's the vision. It's not very specific, but I think you kind of get the picture of where we want to be. That's it. Thank you very much.
How are you, sir? Any questions online? Excellent question.
Do you have any questions in the room? First of all,
Let's do that first. Well,
I'm going to ask an awkward one. Sorry, Julie.
This is about George. I'm going to put it back to you to answer.
No. It's just that obviously money is really tight at the moment, and we keep being pushed for MVP. How can we promote the benefits, or is that part of the strategy that you're working on, of actually doing that little bit more for the good of the future?
Yeah, I think in terms of minimum viable product, absolutely. I think this comes under the viable work part of it. That why would we be building something if it's going to be falling over in 20 years and it's got an asset life of 60 years? To me, that comes very much under the viability.
One of the things I think maybe you should also consider is the fact that people do not coordinate. So Network Rail is a railway company. One of your first images showed the railway flooded and the water was coming from a road, which is not railway. And the recent images of Network Rail being canals is also the same, because you've got green fields right next to the canal. Brunel did a lot of drainage, but he basically did drainage for his time, and his drains were brand new at the time. But often they're sort of seepage drains and things like that. And they fill up, and they need maintaining. They need cleaning out and doing things like that. The last time I walked on track was when it was rail track, not Network Rail, and my experience of walking on track was noticing lots of drains with no covers, sticks dumped into them and stuff like that, and nobody did anything, because if you did anything, it was then your time, and then you couldn't do your work. So they didn't do that. Network Rail have a phone line that you can report things.
Yeah.
But that's just for track. What about where civils, for instance, or councils have open track, open channels going into drainage, or open drains, or drains with just surface drains which are supposed to seep into pipe, but then that's covered by leaves and all sorts of stuff. Those then become open channels rather than drains that lead into other drainage away from the track. I've actually seen things where drainage is actually fed into cut-ins and things like that. And the recent pictures that I've seen actually highlight that maybe all that water isn't actually going from the track or other places. It's coming from other civils, other councils and other things like that, but they're not coordinating with track, possibly.
So I think we have come a long way in terms of our asset management, and now I sit within the engineering and asset management part of the organisation. I can see that we've done a huge amount just in the last 5 years in terms of our asset database for drainage. You know, there's loads and loads of hidden drainage assets we didn't even know about because they were buried. We've come a huge way in kind of uncovering that, knowing more about it, and in having dedicated drainage teams to go out there and deal with looking at root causes, but also just in terms of clearing debris and trash screens and so on. So I think I have to sort of defend the team that I now sit within, and actually we've come a long way. Having said that, we've got further to go. We have got somebody that has got a foot within the Environment Agency and Network Rail sat within our organisation. So he's been here for probably about 8 years now, I'd say, and he so we're liaising closely with the Environment Agency. So where the Environment Agency will manages water courses, and so that liaison is happening. In terms of highways and other landowners, I think that we do need to be talking to other sectors and councils when we're talking about adaptation, because it might be as well as all the reasons you mentioned. We also think about
category 9
and where we're going to be, you know, where we're going to be making resilient, and does it fit with kind of a regional strategy? Because, you know, if we put in a sea defence, then it will benefit not just the railway, but potentially highways, potentially power, you know, other infrastructure providers, and vice versa. So I think, yeah, we do need that kind of cross-sector conversation. And so I've got myself involved in the South West Infrastructure Partnership to do that. And there's other bodies as well. So yeah, good point.
Can we take one online? Joan, are you there?
Yes, I'm here. Thank you. Thank you. Thank you very much, Julie. That was a really excellent presentation. So my question does come back again a bit related to money. And I see in, you know, various posts, etc., all around the place that Network Rail have now got their CP7 settlement. So I was interested to understand from the perspective of the ORR, do they give you specific monies now to address climate change and weather problems, or is it just sort of, here's the pot of money, divvy it up as best you see fit?
I think in terms of asset renewals, that's something I'm trying to get under the skin of a bit more now. I do know that we definitely do have ring-fenced money for resilience schemes in the next control period. So we can start looking at weather resilience and how, you know, and adaptation. And it's a relatively small amount, but it's still, it will deal with a number of resilience schemes in the control period. And we do have dedicated funding to do the adaptation pathways piece of work. So even if it doesn't happen kind of globally fully in CP 7, then we can certainly start that in CP 8 in the next control period. So starting in 5 years' time.
Thank you. Thanks.
Well, we got Lawrence Walton.
Hi, Julie. Thank you for a fantastic presentation. I really enjoyed that. In terms of temperature resilience, I note that the impacts of that are fairly low compared to some of the others. But are there studies underway that consider raising of stress-free temperature in line with temperature increase that might prove fruitful?
So I don't know the answer to that. I don't know if anyone in the room does. But what I can tell you is that that the changes that happened to the standard, the track 001 standard since summer 2022, and we're in place for this summer, would have made a massive difference if we'd had the temperatures, which of course we didn't. But they would have made a massive difference just because they recognise actually some of the quality of the rail that we have these days can withstand greater amount of heat. So
I think just the new version of track construction standard for newly installed track now, the SFT is higher.
Is it? Okay,
Yeah.
brilliant, thanks.
There's another
Do you know how high it is?
Do you know, I can't, because I don't do much pure track anymore, so I remember seeing it. I don't know whether anyone else.
About just 1 degree or something. It
It's
wasn't much.
It was 27, and
It was,
was it? And now
yeah.
has it gone up to 28?
it was higher. Richard Gibson might know.
Yeah, I thought I'd just sort of butt in on it a bit. So basically we have looked at, sorry, for those who don't know, I'm Rich Gibbs, I'm Principal Engineer in the Track Frameworks and Assurance team. So I'm the lead on hot weather and kind of led the working group for the Mod 14 and that kind of stuff. So within the TA, we've been looking at the possibilities of raising the SFT from 27. The calculations for the range that we get are still valid, although we are looking at what they're doing elsewhere. Other areas, they may have it at 30, 32, that kind of thing. But we're looking into that side of stuff. For new track, for new rail, we're now stressing to 30 degrees. And that's on the basis that we still believe that you get an initial loss of 3 degrees. So basically that is to put us, to stop us starting on the back foot when we stress to 27, and then we end up with a stress-free temperature that is halfway between our tolerance of 21 to 27 due to that initial 3 degrees loss. So rather than losing that 50% of our range straight away, the decision's been made to stress new rail up to 30 degrees with a view that that will come down to 27 in a short period of time, and we'll end up at the top of our range and gives a fighting chance. But as far as the stress-free temperature is concerned, there's still a lot of R&D work going on around this, so we are still looking at whether we can raise that up or if we're at the right level with 27 at the minute.
Brilliant, thank you.
Thank you.
Thanks for the answers.
I actually have a question, if I can. Can I jump in? So a lot of the schemes you've talked about are reactionary almost. They're known problem sites. Is there any work going on to identify future problem sites based on known areas of where sea level might rise or anything like that?
So that should all be picked up in the adaptation pathways piece in the next 5 years. But I think as the kind of resilience graph showed, I think we've got a long way to go just to get to a deal with our existing sites.
Yeah.
If we can deal with our existing sites and make them also climate resilient, so they're then dealt with, then we can
Start looking forward.
maybe 20 years from now.
Yeah, my question was going to be on the similar lines, actually, on the viability of costs and the cost if it goes wrong. Nick Blenkamp from Seven Partnership, by the way. We did all the survey for Dawlish with mobile mapping teams on quad bikes and mobile ground penetrating radar. But it just strikes with your little graph there on the 3 things that were impacting cost when it happens. If there's funding available to actually preemptively go around in a boat or a barge, multi-beam sonar, scanner on the top, quantify how much the spit's gone, or push ground penetrating radar down the railway and note this is where the burrows are, this is where the water would come through, in areas of potential high risk.
Yeah, I think that could be because I think when we start looking at the adaptation pathway for that Powden Banks area, then it could end up being quite a costly scheme. So it might be that we need to prioritise a bit and have a kind of early priority phase of work. So that sort of
Also,
survey.
doctors, colleague said here,
Coordination.
coordination. We will go and scan a project for a track lower or for a claim line renewals, but then that data doesn't get passed to you guys who might need it for something else.
Yeah.
I mean, it's Network Rail's a massive organisation. It's a nightmare to coordinate, but even just somebody going, actually, if you're working in these areas, stick a flag up, give you the data, post it on Sensat or a platform that's online.
We've had quite a good forum as part of the South West Rail Resilience Programme called I can't remember what it was called, interagency kind of meeting, which is, so we ended up with some really good collaboration with the council and the Environment Agency. So it's kind of broadening that out, I think, that we probably need to do. So we ended up doing things like sharing materials, sharing data. So it was definitely a beneficial thing to do. But those opportunities only arose because we were talking regularly and found out about it.
Yeah, it's interestingly in the strategy where that whole route was looked at, Powderham is one of the next ones after the 5 that we've tackled, and it's kind of like, oh, and that whole has just demonstrated that it was right.
Yeah.
Good and bad.
Yeah.
Gary?
I've got a couple of comments in the chat, and then I'll ask a question if that's okay.
Yeah, go for it.
David O'Connor's pointing out that there's been a lot of work done to increase resilience recently, and just stressing the importance of collaboration with other agencies and departments, which is Carsten's point as well. Jay Carroll has provided a link in the chat to Network Rail's adaptation report, which does have a section on independencies with third parties as well, so that's worth having a read. My question about overhead line, you have 2 or 3 of us overhead line people here, as well as all the track people. We have the same problem that track do about the operating temperature range, where the upper limit's going up, but the lower limit isn't necessarily going up to follow it. But the other area that we worry about a lot is wind.
Right.
And crucially, the deflection on the wires, and that's sometimes the point at which you decide to shut a railway. It's part of the decision about shutting a railway in a really bad storm is that risk of the wire coming off the pantograph.
Yeah.
Is there any work being done on, because I read lots of general stuff saying there's going to be more energy in the Atlantic. We can look forward to more storms, more extreme storms, higher wind speeds. Is Network Rail doing any work on that aspect of?
So yes, it's a really pertinent question as well with Kieran on the way, isn't it? So in terms of like the climate impacts, which I think you sounds like you're aware of anyway, but wind is very, very hard to predict. But what the models show is that there's not really any change in kind of average or even peak wind speed, but so winds aren't necessarily going to be getting stronger, but that the amount of the tracks, what they can look at is the tracks of the winter storm. So, some winters we have storm after storm coming over the Atlantic and hitting us, like we had Dudley, Eunice, Franklin within like a couple of weeks, didn't we, a couple of years ago? And other winters we have a big blocking anticyclone and they all go north, and we don't, or south, and we don't get any. So the models have looked at what are the patterns that give us the most problems with wind, and what are we likely to get with climate change, and that shows that we are likely to get more stormy days, but then maybe the wind speed is dropping on other days because the average didn't see any difference.
If you look at your statistics, before there weren't as many electrified tracks. Now there are a lot more. So this is going to become a bigger problem in the future.
Yes,
although we are getting much better at managing how much deflection that we design into the system. Previously, in the 1980s and 90s, we would have maximised spans, and the tensions weren't high enough, frankly, to allow that amount of deflection.
That's Series 1 now, isn't it? Have you got SNF?
Series 1 is not going to be a problem for blow off, I don't think. It probably helps slightly that we got an east-west railway rather than a north-south railway.
Yes, but certainly, I mean, when I talked to Dave Hewings about OLE issues, he's very confident about his Series 1 stuff.
we've got high tensions, and our average span is shorter than most electrified railways. Having said that, we're doing a lot of work now. Network are doing a lot of work to reduce electrification costs by increasing span lengths again. So we're going back, feels like we're going back the other way, and
that's on projects that are north-south.
yes, it is. Yeah.
Mm.
So that,
That's really
yeah,
yeah. So
there's got to be a careful balance there, isn't there? That we don't push it too far. Then end up with a log problem again.
Yeah.
Thanks.
Okay, I make it 10 to 2. So I think we've got one more question online. So can we take that?
So George Cropford, apologies if I've got your pronounced that wrong, George. Great presentation, thank you. You must get this every time you present something like this. George would like to talk about the inland route between Oakhampton and Plymouth. And are we going to rebuild it? What would it cost? Would it pass a cost benefit analysis?
It doesn't pass cost benefit analysis just to do it for resilience, because we looked at that straight after 2014. So that was one of the first things that was done before we looked at the study that I've talked about and Emma's talked about with all the priority sites. Before we did that, we looked at actually, should we be investing in this line at all, or should we be looking at alternatives? And that didn't have a case that stacked up, primarily because unless you completely close the coastal route, you've then got 2 lines to maintain instead of 1. However, it is something I believe that is still being looked at. There's lots of local stakeholders on the peninsula that want it to happen for other reasons, and it would have the benefit of then also being a kind of a secondary route if we had any problems. So
I think it's
how much would it cost?
Section, isn't it?
Yes.
Where a lot of the land was sold off and is used by others.
Yeah. So basically, it hugs sort of top of Dartmoor. So I don't know the cost, but I do know that there is some work going on. And I think if you spoke to Bogdan Lupo, is it a Network Rail person that's asked the question?
I'm not sure. Don't know George. So.
Yeah. Okay. Well.
Yes.
So people within Francis McGarry's organisation will probably know more. So Bogdan Lupo and team.
There was a lot of stuff when we actually reopened the bit we have reopened. That's obviously a single track as well. We put it in the middle, in the best place. And if you made it viable with the 2 tracks, there was just a massive amount of work. So it depends what they end up doing. And it's quite a windy, certain bits are quite windy over the speed you can get out of it.
That's a track technical term for
Civil engineer.
Okay, I think we'll start to wind up. So thank you, Julie, and can we give Julie another round? I think that's you know, the thing that strikes me, all the graphs and all the statistics show that this isn't a linear change, and that as things start to deteriorate, the deterioration rate tends to increase. So you know, the sooner we all act and we start to include this thinking into our design work and what we do, the better. That's really disconcerting. So yeah, please take that thought away. I know not everybody here works in design, but we've all got a part to play at some point in the process of managing, maintaining rail infrastructure. So take that thought away. Really good to see a good turnout here in Swindon, and also a great turnout online. So thank you all for making that effort. Just a reminder, our next session, 29th of November. We'll send the details out fairly soon. A couple of quick thank yous, Gary and your Atkins colleagues, for hosting us again here in Swindon, and for operating the technology, for which I wouldn't have a clue. And Simon Warren, our secretary, who notifies everybody, although he had some issues with the email this time. But Simon does a great job of keeping us all in check and keeping these meetings ticking over. So thank you, Simon. And thank you, everyone online. See you in a month.
Right.
I ask for a couple of volunteers from the Atkins team just to help me put the room back.
Just